Limiting reactant solution stoichiometry. So here's just a quick example of solution stoichiometry with a limiting reactant question. You know it's a limiting reactant question because they have two reactants. Here's potassium iodide reacting with lead 2 nitrate. And they give the amount of potassium iodide and the amount of lead 2 nitrate. So you have to figure out if one of them runs out first, which one produces the least amount of product. That will be the limiting reactant. And then the question is asking specifically, what is the mass of the precipitate? So we want to go to grams. We need to know which of the products would be the precipitate. So like any stoichiometry question, you want to start off with a reaction. So you write the balanced chemical reaction for this reaction, potassium iodide combining with lead 2 nitrate, double displacement reaction, make sure it's balanced. You should get this. Using your solubility table, you can confirm that the potassium iodide and lead 2 nitrate are aqueous. As for the products, on a solubility table, you'll see lead nitrate will be aqueous, as with any nitrates. And sorry, I said lead. Potassium nitrate would be aqueous, and lead 2 iodide is solid. So that is going to be the precipitate that we're going to be finding. And when we go to do our calculation, it would be the product we'd want to find the mass of. We could find which one's limiting by solving for the other reactant, but the question is specifically asking for lead iodide, so that's the one we're going to use. Also remember, capital M, short form for saying what the molar concentration of these solutions are in moles per liter. So, with any solution stoichiometry problem, we're going to start with two sets of calculation. So we have to do the work for potassium iodide, and we have to do the work for lead nitrate. There's the work for lead iodide answer already. Given that we have a volume and a concentration, so we have the volume and we have the concentration, and if we're going to be using the amount of potassium iodide to convert to amount of lead nitrate and of lead iodide, sorry, and the amount of lead nitrate to also solve for the amount of lead iodide, we have to be in moles to do that. So we're going to use the volume and the concentration to go to moles so that we can then convert to our product. We have to be in moles first. So we could use C equals N over V, and we have our V and we have our C, so we'd be solving for N. We would then apply the mole ratio to convert over to our product and then convert to mass. But we want to try to do that a little bit quicker using conversion factor. So I'm going to start with the volume, and I've converted that to liters, but again we have 25 milliliters. And if you want to use a conversion factor, if you don't want to do it in your head, you can use a conversion factor that would put milliliters in the bottom and liters up top. We know that 1 liter has 1,000 milliliters in it. So 25 milliliters would be divided by 1,000 to get you to your liters, crossing off milliliters, giving you your 0.025 liters. So if I want to go to moles with that, I've got to get rid of liters. So my conversion factor has to put liters on the bottom. The concentration gives me that ratio. It gives me how many moles there are per liter. So as long as I set it up like this, which has liters in the bottom, they will cancel out, and now I'll be in moles of potassium iodide. Then I can convert to moles of product with my next conversion factor. That'll get me out of moles of potassium iodide and into moles of lead 2 iodide. And then the question is asking for the mass of the precipitate, so I want to use the molar mass of the lead 2 iodide. That will get rid of my moles, and I'll be in grams, and that is the mass of product, solid product, precipitate, that I could get from the potassium iodide. Now, there's also some lead nitrate there that is not unlimited. So based on how much lead nitrate we have to see how much product we could also get. So same thing, I'm going to take the volume, I'm going to use the concentration to cancel out the liters, and now I'm in moles of lead nitrate. I can convert to lead iodide by putting moles of lead nitrate on the bottom, moles of lead 2 iodide up top, and then again I would go to mass using the molar mass, and I would get that as the mass of precipitate that could be formed with lead nitrate if I had enough potassium iodide. This is a larger number. It could never actually be made because the potassium iodide can only make 0.864 grams. So I'd never be able to make any more than 0.864 grams of product. This number cannot be used. There would only be 0.864 grams of lead 2 iodide produced because potassium iodide is limiting. Very similar to what we did before, we're just using a slightly different way of getting to moles. We're using volume and concentration. And again, I'd encourage you to use the conversion factors. As long as you let the units work themselves out to get the units that you want, you do not need to memorize or rearrange equations.